Obama is real. I mean, isn't real. Wait, yeah, not true. Obama isn't real. Yeah, we're not talking about not true stuff. Obama isn't real.
Like the person?
Yeah.
Just isn't real?
No, they're gossiping about me.
No.
They're saying stuff about me.
We said Obama isn't real.
No, that is not.
Yeah, we didn't even say her name. We said Stokely. Yeah. We said Stokely Fun. Stokely Fun.
That is girlfriend.
Okay, let's get started. Okay, so we are talking about properties of real numbers. Okay, in math, properties are statements that are true for any numbers. They justify steps when simplifying expressions and solving equations. Okay, so do I need to repeat it, or are you just confused? Okay, commutative.
Can everyone shut up?
That would be great. Okay.
All right.
Kind of faked me out there, Adam. Do you need something?
No, I'm good.
Okay.
Do you want mine?
Commutative property. Okay. This is dealing with addition or multiplication. Okay. Commutative property says that the order of your values don't matter. Okay. So for instance, A plus B is the same as B plus A. Okay. So if we were to put in real integers for those, like 2 plus 3 is going to be the same as 3 plus 2. Okay. We know this, but it does have a defined rule in math, and that is called the commutative property. Okay. Now, it not just deals with addition, it deals with multiplication. So you have A times B equals the same as B times A. Okay, so you could have 2 times 3, which equals 3 times 2. Those come out to the same product. Yes? Okay. Okay, any questions on that? Pretty straightforward. We're pretty used to that one, right? So associative property. Associative property is again dealing with addition or multiplication. Okay, and this deals with the grouping of values. Okay, so we're saying the grouping of values doesn't matter when dealing with addition or multiplication. Okay, so for instance, we might have an example of A plus B inside parentheses plus C equals any order you want. So we could say A plus B plus C in parentheses. Okay? Doesn't matter where you put the parentheses. That's kind of the gist of this one. Okay? Doesn't matter how you group the different values together. Okay? They will equal the same. So if we do, let's say we do 2 plus 3 plus 4 equals the same as 2 plus, and then in parentheses, 3 plus 4. Okay, so like we said, that was for addition. It's also for multiplication. So we could have A times B times C. Then you could have A times, and then in parentheses, B times C. So we could have 2 times 3 times 4 equals the same as 2 times in parentheses 3 times 4. Why does that work? Yeah, because we're with addition, you're just putting it all together anyway. Okay, or multiplication, the same thing. You're just multiplying them all together. The order that you do those things doesn't necessarily matter. Okay. Identity property. Okay, so identity property, dealing with addition or multiplication. Okay, we're going to say stays the same. So this is dealing with in addition when we add 0. Okay, or in multiplication when we multiply by 1. Okay, let's keep moving. Inverse property. Again, using or working with addition and subtraction. Addition and subtraction. Addition and multiplication. Okay, we are going to use the opposite to cancel a value. Okay, so if we are using a and we are going to add a value that's going to cancel a out, what are we adding? Negative a. Okay, same thing with multiplication. If we are using a, what are we multiplying that's going to cancel out a value? So we're going to use the inverse. Okay, do we remember what the inverse of a would be? Because again, we're working with multiplication. We don't necessarily want it to go down to 0. So if we did a times negative a, you would have negative 2a, right? Okay, that changes the value, okay, by doubling it. But multiplying a number by its inverse, okay, which is 1 over whatever that number is, will give you a over a, which is what? 1. Mm-hmm. Correct. Okay, property of 0. Pretty straightforward. Multiplying by 0 equals 0. Okay, so a times 0 equals 0. Okay, 17 times 0 equals 0. Negative 1 over a times 0 equals 0. Okay, distributive property. Distributive property is when we multiply a value to an expression inside parentheses. Okay, so you can just draw parentheses, or you can write okay. So that looks like we have a times in parentheses B plus C is going to come out to equal AB plus AC. Okay? Now, how do you get that? Yeah. By distribute, what are you doing mathematically? Like operation-wise? Yeah, exactly. Good. Okay? So you multiply the A times the B, that gives you AB. Multiply the A times the C, that gives you AC. Okay? So if we were using some integers and variables, let's say you've got 2 times x plus 7. You're going to take the 2, multiply it by the x, that gives you 2x. You're going to take the 2, multiply it by the 7, that gives you 2 times 7, which is 14. Okay, let's look at another example. So we've got negative 5 times y minus z equals what? Write it down. Okay, somebody let me know. Negative 5y plus 5z. Okay, so you have the negative 5, multiply it by y, you get negative 5y. You have the negative 5, you multiply it by the z. What do you have to attach to that z? The negative, okay? So it's got that little subtraction sign in front of it. So it's a negative z. Negative 5 times a negative z is going to be a positive 5z. Okay? Any questions on that so far? Sweet. Okay, if you've come in late, just catch up with a neighbor's notes, okay, after we get done. But just pick up where we are, okay? Okay, this property is, I would say, the easiest to understand. Reflexive property. Anybody know what it means? Adam, it was a perfect answer. A value always equals what? Itself. A equals A. Okay, so for example, 16 equals 16. Okay, 5x equals 5x. 4y squared equals 4y squared. Always. Now you really know.
Why is this an actual property? Isn't that just
It only became common sense because someone created and established it as a property.
This is the last call for all teachers and students who didn't take a picture. If you have not, please go to the gym.
Oh yeah. All right. I'll see you guys in a second.
Wait, I'll teach it. I'll teach it.
Oh, wait, he's not in here.
leave me Oh yeah.
Wait, is it on the computer? Can someone define the symmetric property?
Symmetry, meaning the
Oh,
both
I know.
on the same.
What? Huh?
Okay, so when one side of an equation or one side of an expression is equal to the other side.
One side of
When two sides. Finish? Finish?
When 2 minus 1
What is this?
When both sides of the equation are equal.
Trying to erase.
Why did I say 2 minus 1 minus 2?
Okay, there you go.
Was I right about that measurement?
Why? Wait, 2 minus 1 minus 2 sides?
He's still cool. What does that say, Adam?
There. Okay.
Was I right?
No, you said 2. Wait, no, 1. No, wait, no, 2 is when 5 goes.
I wouldn't say you were wrong.
Let's go.
Okay. So symmetric property. Okay. If A equals B, then B equals A. Okay. So, for instance, if X equals 3, then three equals X.
So this property is all about equality, right?
Yes, this is a very inclusive property. So 5X equals 30. Then
Did you write that on your paper?
30 equals 5X. 142. Just another hour or so.
Oh my god. That's another hour.
Do not say that.
Wow, I didn't want to hang out with y'all either. So. Okay.
No, it's not that. That's just a long time.
No, that's not what you do.
I don't want to go to finish. So
Oh, yeah.
you can do nothing.
Transitive property. Okay. This is going to use a little bit more reasoning. If A equals B and B equals C, then A equals C. Okay? Yeah, these are all, I mean, math is all common sense.
Not really.
It's all concrete and logical.
No, but
It's just some of it's just complicated. That doesn't make it not common sense. So reflexive property is on both sides, they are the exact same. Okay? We're not implying that they're the same. Symmetric is that they can be flipped. But they're not necessarily like 30 equals 30. We've got 5x equals 30. Whereas with reflexive, you'd have 5x equals 5x. Okay, so they're only slightly different. Okay? Could. Because you could also use symmetric property. So C would also equal A. Yes. Okay, so let's look at an example. If 4 plus 3 equals 7, and 7 equals the square root of 49, then 4 plus 3 equals what? Equals the square root of 49. Say that one more time. Where? Plus. Okay, listen. Last one. Okay, closure property. A set is closed under an operation if the operation always produces an element of the same set. If an element outside the set is produced, the operation is not closed. It's common sense. Okay, so listen. Okay. A set is closed, okay, under an operation if the operation always produces an element of the same set. If an element outside the set is produced, then the operation is not closed. Okay, so you're going to answer these true or false. I would like for you to try and answer them. You've got 5. Okay, I'll give you 2 minutes to work through these. Talk with your neighbors, see if y'all can figure them out. What's up? Natural numbers? Any number. Yep.
Not open. A set is not open.
Under an operation. So you can't use if you're not gonna take it, give me my tissue paper. Oh, my tissue paper. Too bad. I can make it open. I mean, up to 4. 3. Yeah, they would.
I hit your head. Yes, I did. I walked over your head.
Okay, another minute or so.
Were we in the same class? No, two edits a week. I was a master. I mean 7. This is so weird. I forget what 8th grade.
It
It doesn't matter. You said it wrong. You said Theo. What is a Theo?
No. Okay. So I would assume we struggled with this section. Okay. So now that as a class we're done insulting Mr. Bennett's lesson for it being too simple, let me explain this, okay? So, what we're talking about with closure property is like if we look at number 1, okay? It says integers are closed under multiplication. What is an integer?
A number.
It's a number. A whole number, right? Negative or positive, a whole number, okay? What closure property says is depending on the operation. What are our 4 operations?
Addition, subtraction, multiplication, division.
Good. Depending on the operation, the answer that you get is it's still in that same category of number. Okay? So, if I have an integer, let's say I have the number 2, and I multiply it by, give me an integer. 4. Okay? What's the answer? 8. Is 8 an integer? Yes, this is true. Okay? Natural numbers. Natural numbers are any number.
They come from 1.
Yes. Okay? A positive number. Okay?
But it has a 0 is not a natural number.
No, it's not.
Starting from 1.
Starting from 1, so no.
Okay? So, so now, hey, can we focus on this, please? Okay. So, now that we maybe are a little bit more comfortable, see if you can figure this one out. Natural numbers are closed under subtraction. So if we use natural numbers using subtraction, is this closed or not?
Not closed.
Give me an example of it not being closed. 1 minus 2. Yes, or the other one. Okay. What would your answer be? Negative 1. Natural numbers cannot be negative, correct? So that's false. Okay. Now see if you can check number 3, 4, and 5 with what you put. Now that we have a little bit better understanding, and see if you need to fix any real quick. I'll give you 30 seconds. I don't know if it's Mr. Palatini or Miss Clark, but somebody's playing music. Yeah.
Under division? Well, if you do rational numbers
Money.
Adam, I'm gonna do
You
it.
get money.
Adam, I'm gonna do it.
You get lots of money.
I like money.
Well, you did last year. So perfect squares are like when you have an integer, okay, and you can multiply that same integer together. Okay, so like 2 and 2 is 4, so 4 is a perfect square. Like 5 and 5 is 25, 25 is a perfect square. Okay. Yes, exactly. Yep. You would take the square root. Yes, but yes, what you're saying is correct. Yes. Yeah. Okay, number 3. Even numbers are closed under addition. True. You can't get you cannot get a odd number if you just keep adding even numbers together, correct? Okay. What is the most common irrational number? Pi. Okay. So, are irrational numbers closed under division? If I divide pi by pi, what do I get? 1. False. Number 5, perfect squares are closed under subtraction. Give me a perfect square. 16. 16 minus 16. Yeah, we can do that. Okay, 16 minus 16 equals 0. Is 0 a perfect square? Technically, no. Well. Okay. Do you have any questions about that? Sweet. You have homework that you have plenty of time to finish in class. Thank goodness you still have 35 minutes in here. You're welcome.
Okay, would you like red, orange, green, or blue?
Blue.
BLUE. Would you like 1, 2, 5, or 6?
6.
1, 2, 3, 4, 5, 6. 1, 2, 5, or 6?
6.
1, 2, 3, 4, 5, 6. Wait, 1, 2, 5, or 6?
6.
You get money. You're gonna be rich.
Promise?
I don't know. It's on a tissue.